A warm welcome to all the viewers and intellectuals watching this video. We are grateful to have presentation in front of you. We are here to explain our research towards safer roads development and evaluation of an alcohol impaired driver alert system, which is presented under International Conference of Sustainable Communication Networks and Applications. So we are from Vishwakarma Institute of Technology and the author names are given on the screen. So every year countless lives are lost due to accidents, and this is because of the drivers which are driving the vehicles because of alcohol. In the past we believe that everything was on luck only, but now with the use of our technology we have a solution which will save alcohol's leave and other drivers. Before the implementation of our system, the accidents were caused due to drunken driver, and which was very common. Lives were at risk and safety of both the drivers, like both the people, impaired driver and the innocent travelers, was compromised. Emergency services like ambulance often arrived very late, and the consequences were very big. So the present IoT system have made some increase in alerting nearby drivers, but they fall short when it comes to ensuring the safety of the impaired driver. While our solution helps to grow the safety of the driver who is driving and the traveler. So these are the objectives. So our first objective is alerting the driver and warning him. Second is we will slow down the vehicle of the driver. Third is we will alert the other drivers, the nearby drivers, so to ensure their safety. And the fourth objective is we will inform police by messaging them immediately if the driver is drunken. And not only this, we will also detect the signs which are available on the roads, which will ensure the safety of the driver. Over to you, Dhanashri.
So for this research, we have also reviewed some research papers. The first of which was by Munaf Ismail and other co-authors. It was named as Embedded Alcohol Sensing Design and Analysis for Air Samples, which was published in IEEE in the year 2021 in October. It was about evaluating the system by analyzing the air samples and containing varying quantities of alcohol. Also, it aimed at boosting the system's accuracy and sensitivity in the future. So, likewise, we also reviewed another paper which was by Murali Krishna and other co authors, which was titled as Drowsiness and Alcohol Detection with Engine Locking. Now, it was also published in IEEE in the year December 2022. So, it proposed that employ sensors to detect drowsiness and alcohol intake in drivers, and the engine of the vehicle is automatically locked. Also, it aimed to refine the automatic engine locking system to avoid accidents and adding additional features like GPS. Over to you, Vishal.
To accomplish the given objectives, our system architecture compromises the three main systems. First is the Arduino, second is a Node MCU, and third one is a FTDI module. So first of all, the Arduino is responsible for controlling the motor speed and the GPS tracking system with the help of L293T motor driver and LCD board. The second one is a Node MCU, which is responsible for detecting the alcohol presence in the car. So during this system architecture, we have developed one system that transmit the data from Arduino to Node MCU, so such that the Node MCU can upload it to a web. We have accomplished this with the help of TXRX pin, which can be called as a switching mechanism. The third component is in a traffic sign detection module, where the ESP32 camera and FTDI module has been used to detect the road signs. These both three architectures work together in a synchronous manner to give us a desired output. These are the methodologies, or we can say the models, which we have implemented in our system, which works in a synchronized manner to give us a desired output, which we will see one by one in the following videos.
So for our project, we have developed an alcohol detection system using an MQ3 sensor. The MQ3 sensor detects alcohol gas concentration in air and converts these readings into an analog voltage that corresponds to the alcohol level. So the Arduino board compares the measured concentration to a threshold that we have set to 500 parts per million. If the alcohol concentration exceeds the limit, indicates a likely intoxication level, the system triggers the next phases as follows. The next phase is traffic sign recognition to help driver for intoxicated drivers, right? So to address alcohol impaired driving risk, our project combines this alcohol detection with a computer vision component for traffic sign recognition. We utilize an ESP32 cam module along with the OpenCV software. This camera module is configured to detect standard road signs using image classification. As signs are detected, the system sounds out the sign over a speaker to alert the potentially impaired driver. For example, stop signs would trigger an audio warning saying stop sign ahead. So the next module would be explained by Dhanashri.
So another module that our system has is alerting other drivers. So this module we have divided into two parts before alerting the other drivers. First, we are having the LCD which is attached at the back of our vehicle, and another we are having the LED lights which are generally known as parking lights. So these two alerts the other drivers behind, and so the accident will not happen. So another module we are having in our system is GPS tracking. For this, once the MQ3 sensor detects the alcohol, our GPS location is sent to the authorities like police by using this GPS tracking system. Over to you, Vedant.
One of the important and core module which we have in our system is slowing down the vehicle. As the driver is drunken, he don't know how to drive the vehicle, right? So we will be slowing down his vehicle and parking it little side by through PWM signal, which will be sent to the motor, which is available in every car. Our circuit will run, which will be available or integrated into the car only, which will slightly slow down the speed of the motor and completely will stop the vehicle after a while. This uses signal controls and makes the motor powerless. We'll see next modules followed by alerting police using telegram bot.
The next model which we are saying is alerting police using a Telegram bot. To ensure this functionality, we have used a Telegram API with the consent of a driver's data that is sent over a network to a Telegram bot using the Telegram API. So the main goal of the Telegram bot is to ensure that the only infected driver does not alerted, but the concerned authorities are also.
This was all about our project and our research. So let us conclude the presentation now. Our system plays an important role and is a fully unique system which will address the road sign drunk driver and which will contribute into the safer roads. And let's save the accidents with the use of our system. These are some of the references we gone through. At the end, we would like to thank Vishwakarma Institute of Technology, and we would also like to thank these conference who keep on arranging such research conferences. If you have any questions, we request you to send the questions on to vedant.savant22@vit.edu. Thank you so much for attending this.